Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on Graham's law. So let's get started. A container initially holds 10 grams of argon gas. After 30 minutes, 4 grams of the gas have effused out. Under the same condition, what is the mass of helium diffused in the same time period, given that the molar mass of argon and helium are 36.95 grams per mole and 4 grams per mole respectively? Alright, so for this question, we are going to calculate what is the number of mole for argon beforehand. So the number of mole is equivalent to mass of argon effused divided by the molar mass of argon. Right, so basically, here it says that 4 grams of argon have been effused out from the container. So mass of argon effused is equivalent to 4 grams. And the molar mass of the argon is given in the question, which is 36.95 grams. So basically, the number of mole for argon that has been effused out is equivalent to 0.1001 mole. Alright, from here we can actually find the rate. So the rate is equivalent to the number of mole, which is 0.1001 mole divided by the time taken. So the time taken is 30 minutes. So you need to convert into seconds, so times 60 seconds. Therefore, you should get 5.5625 times 10 to the power of negative 5 mole per second. So this is the rate of effusion for argon gas. Alright, so because in the question, it wants under the same condition, what is the mass of helium gas diffused at the same time period, right? So we need to find what is the rate for helium. So rate for helium, we divide by the rate for argon. This is rate of diffusion, okay? So it's equivalent to the square root of the molar mass of argon divided by the molar mass of helium. Okay, so the rate of argon we have calculated before just now. So we can write rate of helium divided by 5.5625 times 10 to the power of negative 5 is equivalent to the square root of 36.95 divided by 4. Alright, so we just have to calculate this part. So rate of helium should be equivalent to 5.5625 times 10 to the power of negative 5, and then you times the value for this one, which is equivalent to 3.1603. Therefore, you will get the rate of helium should be equivalent to 1.7579 times 10 to the power of negative 4 mole per second. Right. But this is not the end because you were asked to find the mass. So what we are going to do now is we are going to find the rate first, then only we can find the mass. Alright, so from our previous calculation, we know that the rate for helium, the effusion of helium will be 1.7579 times 10 to the power of negative 4 mole per second. So we are going to use this to calculate the number of moles. So the rate is mole per second, right? So it's going to be 1.7579 times 10 to the power of negative 4 is equivalent to the number of mole per second. So how many seconds are there? Because they said that diffuse at the same time period, right? But here it states that it is 30 minutes. So same goes 30 times 60. So the number of mole should be equivalent to 1.7579 times 10 to the power of negative 4 times 30 times 60. So you should get the number of moles should be equivalent to 3.1642 times 10 to the power of negative 1 mole. Right. So from here, we are going to calculate the mass of helium by using the number of mole. Alright, so from the previous calculation, we know that the number of mole of helium is equivalent to 3.1642 times 10 to the power of negative 1. So therefore, we have the number of mole is equivalent to mass over molar mass. Right? So we can calculate the mass is equivalent to the number of mole, 3.1642 times 10 to the power of negative 1 times the molar mass of helium. So given the molar mass of helium is 4 gram per mole, therefore you should get the mass of helium that shall be effused out by using the same period of time should be equivalent to 1.2657 gram. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.